Hey folks, we're up to chapter 1, lesson 3, locating points and midpoints. All right, this is a line. It's the line AB. There's also the line segment AB, and it has a midpoint, a halfway point, that divides AB into AM and MB. We say M is the midpoint of AB if and only if M is between A and B and AM equals MB. All right, we want to find the midpoint of this line segment in R1. I'll remind you, in R1, you can't move on a plane just on a line. All right, find the midpoint of AB. How are we going to do that? Here's what we're going to do. We're going to say the midpoint is going to be the value of A, which is x of 1, plus the value of B, which is x sub 2, divided by 2. It's kind of like this. Let's say you got 100 on one test, and you got an 80 on another test. What would you say your test average is? You'd say 90. How do you come up with that? Do you remember? 100 plus 80 divided by 2. Yeah, that's 90. Likewise, if you had 3 test grades, how would you get the average grade? You'd add the 3 tests and divide by 3. That's what we're doing here. It may not look that way, that's exactly what we're doing. We have a value for A, a value for B, and we want to get its average value, which is going to be halfway in between. So we add A plus B divided by 2. That's how you get a midpoint in R1. All right, so how about this? What's the midpoint of line segment BD? It's going to be 80, obviously. How do we get it? 70 plus 90 divided by 2. All right, one more. We're going to find the midpoint M of AB when A equals -4 and B equals 3.
Amara Watson. Amara Watson, please beat your ride in the front parking loop. Amara Watson, please beat your ride in the front parking loop. Thank you.
So what are we going to do? How do we get -1/2? -4 plus 4, sorry, -4 plus 3 divided by 2, which is -1/2. All right, let's try to expand our thinking and move into R2. You know R2 is a little more complex than R1, but R2 always builds up by getting some information from one version of R1 and another version of R1. X, number line in itself, is just R1. Y, number line itself, is just R1. So let's try this out. We want to find the midpoint of this line segment in R2. We want to find the midpoint of line segment YK. How are we going to do it? We're going to break up this R2 into an R1 and an R1. So to find the midpoint M, first thing you want to do is drop a right triangle. We're not going to use Pythagoras here, but we are going to look at the base of the triangle again, and we're going to find the midpoint of the base. So how do you find the midpoint of the base? Just like we did in R1. Let's look at a horizontal line. Okay, so the base is going to be what? X1 plus X2 divided by 2. That's how we're going to get the midpoint of the base. How do you think we're going to get the midpoint of the height? The height is still R1. It's like an R1 in this direction. How do you get midpoint in R1? It would be top plus bottom divided by 2. Yeah? Okay. So y1 plus y2 divided by 2. Now, what are we trying to find? The midpoint of JK, this ordered pair right here. So this will be an ordered pair because it's an R2. Do we have any more work to do? No, we've gotten all the information for the ordered pair. An ordered pair involves 2 real numbers, real number, comma, real number. That's my first real number, that's my second real number. So my midpoint will be at x1 plus x2 over 2, comma, y1 plus y2 over 2. Can you see it? You're going to go over this far and up this much. over this far, up this much. Okay, let's try an example with numbers. Find the midpoint of AB. So what's the first thing I'm going to do? Well, first thing I'm going to do is drop that diagonal. Drop the right triangle. And then I'm going to ignore everything in the y direction. I'm just going to focus on this x portion, the base. And I'm going to get the midpoint of the base. How do we do that? Simple average. All right, we got 1, and we got 5, so 1 plus 5 divided by 2. How about the height? How am I going to get the height? Ignore everything else and just, to get the midpoint of the height, take a simple average of what two numbers? 2 and 5. Great. So, do I have any work left to do? No, I'm done. That's the x coordinate, that's the y coordinate of m. Go over this far, go up this much. 3, that's 3, and that's 7 halves. All right, let's try one more. I'll find the midpoint of EF. What do we do? Right triangle. What am I going to ignore? Everything except the base. That's like happening in R1, that's happening in the x-axis. What do? -6 plus 1 divided by 2. That'll be the midpoint. For the base, how about the height? Again, height's just dealing with y, so it's being like an R1. 3 plus, what's this value right here? 0. The x-axis is always y equals 0, so 3 plus 0 divided by 2. All right, that's 3 halves. So the midpoint is at -5/3. This is -5/3, comma 3 halves. You see, once we got the x and the y coordinates, we're done. Whew. This is harder. So there's about 4 iterations of difficulty here. That was the first iteration. The second one is this. Find the coordinates of j if m, 0, 1 is the midpoint of JL and L has the coordinates 3, -5. Your first thought is probably, where's J? I don't see a J at all. I know where M is, it's at 0, 1, and I know where L is, it's at 3, -5. But where's J? So where's JL? Well, understand what you're looking at. That's the midpoint of JL. That's the endpoint of JL. The only thing you're missing is what? The other endpoint of JL. So your brain, probably on paper, you need to show this. That's what you're going for, right? You don't know where J is, and you're trying to find J. You're trying to find that endpoint. Given the midpoint and one of the endpoints, find the other endpoint. So what are we going to do? It's not quite reverse engineering. It's using the same information, but in a different way. Now, you're not just going to guesstimate using a ruler here. You're going to do the algebra. So what do? Well, we know the midpoint formula. The midpoint is always going to be x1 plus x2 over 2, y1 plus y2 over 2. Do I already know the coordinates for the midpoint? Yes, they are 0, 1. So in place of m, I can put 0, 1. Hey, do I already know the coordinates for L, which is x2, y2? Yeah, it's 3, -5. So for x2, y2, I'll put in 3 and -5. Great, now what? This looks like one equation, but really it's 2 equations. It's 0 equals x1 plus 3 over 2, and 1 equals y1 minus 5 over 2. So you gotta create 2 equations here. First equation, second equation. Now are you done? Yeah, you're done now, because you have the x1 and y1 coordinates of what order pair?
Miguel Renteria, please go get your ride in the back. Miguel Renteria, please get your ride in the back.
Okay, so let's see, does that look right? -3, 7, yes. Now you're probably asking yourself, do I really understand the algebra that happened right here? Well, let's find out. 0 equals x1 plus 3 over 2. What am I going to do? Multiply both sides by 2. What's 0 times 2? 0. What's x1 plus 3 over 2 times 2? 2's cancel out, and you're left with x1 plus 3. Right, and just bring 3 to the other side.
Jeremiah LeBaron. Jeremiah LeBaron, please come to the office.
All right, same thing over here. 1 equals y1 minus 5 over 2. What do I do to both sides? Multiply by 2. 2 times 1 is 2. Here, multiply by 2, so 2 over 2 equals 1. The multiplicative identity, the 2's cancel, and you're left with y1 minus 5. So finally, j has the coordinates negative 3, 7. Let's try another one. Find the coordinates of j if m, which is at 0.5 comma 0, is the midpoint of JL, and L has the coordinates 2, negative 3. Again, I have to say to myself, what J? I only have the coordinates for M and L, so what does this mean? Oh, I got you. You're giving me a midpoint and endpoint. You want me to find the other endpoint, which you're calling J. How am I going to do this? You go to the midpoint formula. You bring in the algebra. You already know. Midpoint is going to be, what does this represent? x1 plus x2 over 2, what does that represent? The midpoint of the base. And what does y1 plus y2 over 2 represent? The midpoint of the height. Good. So, I already know the midpoint. It's at 1/2 comma 0. So in place of m, it's 1/2 comma 0. I already know x2, y2. That's this ordered pair L, which is 2, negative 3. So I'll plug in 2 and negative 3. Looks like I have one equation, but I really have 2. What 2 equations? 0.5 equals this, and 0 equals that. So 0.5 equals this, 0 equals that. Now, am I done? I'm done. I've got the coordinates for j. x1, y1 is j. And what are they? Negative 1, 3. Looks right based on my graph. All right, come over here. Let's make sure our algebra is okay. What am I multiplying both sides by? 2. What's 2 times 0.5? 1. That's like 2 times a half. What's 1/2 of 2? 1. Okay, how about over here? What am I multiplying both sides by? 2. What's 2 times 0? 0. And then y1 minus 3 over 2 times 2. The 2's cancel and you're left with this. All right. Onward. Next level of difficulty. You ready? Find x on AF that is 1/6 the distance from A to F. So what am I saying? I'm saying A is at x equals negative 4. F is at x equals 4. And somewhere on my journey from A to F, if I go about 1/6 of, if I go 1/6 of the distance, maybe that's up to here or so, that location right there will be called x, and it'll have some particular value. X equals something. How are we going to get there? Here's the plan. You're going to start by getting the entire length AF. Well, you know how to do that, right minus left. I think it's 8. Then I want to take 1/6 of that distance. I only want 1/6 of the distance. Well, how do I take 1/6 of anything? Multiply that thing by 1/6. All right, so 1/6 times 8, which is 8/6 or 4/3. But what I have now is a distance. I have a distance like approximately this wide. Maybe that's 1/6 of this whole line. But I'm not looking for a distance. I'm looking for a location x. So to get any location x over here, I need to have 2 ingredients, not just a distance, but I need a starting point. To get to an ending point, you need a starting point, a distance, and then an ending point. So here's what I'm going to do. I'm going to take that distance of 4/3, and I'm going to add it to my starting point, which is negative 4. Starting point, negative 4, plus distance, 4/3, gets me to this new location, which is negative 8/3, and that is the location of x. X is at negative 8/3. Let me try to explain this to you if it's still confusing. If I have a house, and it's at 100 mile marker on the highway. So here's a highway going, and I live at the 100 mile marker. My friend lives 20 miles past me. What mile marker do they live at? You should say mile marker 120, and you'd be right. So how far do we live apart? 20 miles. That distance is not enough. I need to know the starting point, which is mile marker 100. I need the distance, which is 20 miles, and then I can calculate the location of my friend's house, which is 100 plus 20, or 120 mile marker. That's what's going on here. Let me just repeat what's going on here. First, you get the whole length AF, right minus left. Then you want only 1/6 that length, so you multiply times 1/6, and you get 4/3. But that distance isn't enough. I need a starting point to add the distance to get my ending point. My starting point is A, which is x equals -4. X equals -4, then I'm gonna add this little bit of distance, which is 4/3, and I get -8/3. That then is the location of my ending point, x. All right, one more. Find x on AF, that is 1/3 of the distance from A to F. Well, when you think you're gonna eyeball it right off the bat, you're like, this is a distance of 6, so 1/3 is about 2. So we should wind up at -2. But I want you to understand how to do this and show the work. So let's think about it. What am I gonna do? Okay, total up the distance from A to F, right minus left, which is 6. Multiply it times 1/3. To take 1/3 of anything, I just multiply the thing by 1/3. So I get 1/3 times 6, which is 2. Now I have a distance. I want to get an ending point x, right? As we know, it's going to be a -2. I have this distance. I know I want an ending point -2, but the distance is not enough. Knowing 2 is not enough. I need a starting point plus the distance traveled gets me to my new point, right? Again, it's like you live at mile marker 100 and your friend lives 20 miles later, they live at mile marker 120, but you needed the starting point, mile marker 100, and the distance, which is 20, to get 120 as an ending point. So, what's my starting point? A is at -4, distance traveled is 2, -4 plus 2 is -2, so that's the ending point or the location of x. All right, next level. Keep moving through levels of difficulty here. Same thing, we want to find R, which is 1/4 the distance from N to M, but we're no longer in R1, we're back in R2. So how do you think you're going to approach this problem? I think you know, you're going to probably draw a right triangle. You can either drop it down here or up here. I dropped it up here. What do you think you're going to do? You know how this works now. You ignore everything else except for the base. Ignore everything except for basically R1, that's the x-axis. And you're going to get, if you're ignoring all this, you're just looking at this base here. You would want to move from N to M, just thinking about the x-coordinates. How far? 1/4 of the way from here to here. So maybe you want to move all the way to right to here. Right? You just want to move from here to here. How do you find this location, this exact x value? Well, you do what we just did in R1 on the base. What do? We get the distance from N to M in the x direction is 2 minus -3, which is 5. Then you take 1/4 of it, so you multiply 5 times 1/4, get 5/4. And again, you need a starting point to add the distance to. What's your starting x value? -3. So starting value of -3 plus 5/4 gets you to -7/4, which is right about there. You just found the point R that is 1/4 of the way to M, only in the x direction. Now you're going to repeat the same thing in the y direction. All right, you want to get 1/4 of the distance from N up towards M, so it'd be right about here. What do? Okay, I need to get this distance first, which is top minus bottom, so 3 minus -3 is 6. Then I take 1/4 of it, multiply it times 1/4. And then finally, what am I going to do with that distance? I'm going to add it to my starting point. My starting point is N, not M. Why N? Because I'm moving from N to M. I'm moving like from N to M, that direction. So I start off with y equals -3, and I add to it 3/2, and I wind up with -3/2 right there. All right, so do I have all the information I need? Yeah, absolutely. That's my x-coordinate, that's my y-coordinate of the point R that is 1/4 of the way from N to M. So it's right about here. Let me show you that. -7/4, -3/2. -7/4, -3/2 right there. All right, it's a little more difficult. All right, let's move on. Last example of this kind of problem. We want to move from n to m, we're going to go 1/5 of the way, so maybe right about here-ish. Somewhere around like 2, 1, maybe a little further than that. Let's find out. How do I do this? You know it, drop the right triangle, I dropped it up top. Only focus on this R1 idea, base. Okay, I want to find out, go 1/5 of the way from here to M along the base, maybe this far. How do I do that? You know how I do this. Right minus left, 6 minus 1 gets you 5. 1/5 of 5 is 1. That's again a distance, but I need a starting point to add my distance to get the ending point. So my starting point is x equals, what is that, 1? So 1 plus the distance of 1 gets me to 2. Okay, so in fact, 2 is right here. Now I've got to repeat this in the y direction. I need to go 1/5 the distance from from n up to m. So maybe right about there, from m up to n. Where's that going to be? Well, we start bringing that distance. Top minus bottom, right? 6 minus 0 is 6. And then 1/5 of 6 is multiply times 1/5, you get 6/5. I need a starting point. What is my starting y value? Is it 6 or is it 0? It's 0 because I'm moving from n all the way up to m, like that. So I'm going to start with n equals 0, and I'm going to add, so y equals 0 right there. Add 6/5 gets me to 6/5. Am I done? I'm done. Got my x coordinate, my y coordinate of r, which is 1/5 of the way up. And it's at 2 6/5. That's 2 6/5 right about there. Very close to where we originally thought it might be. Wow, that's a lot. I will tell you, lesson 3 is hard because of all this geometry and algebra, but lesson 4 will be much easier. We have one more thing to do in lesson 3. Actually, 2 more things to do in lesson 3. So let's get those done. First, a segment bisector intersects a line segment at its midpoint, dividing the line segment into 2 congruent line segments. Okay. A segment bisector intersects a line, the line AB, at its midpoint, M, dividing the line segment into 2 congruent line segments. That's 2 line segments of equal measure. Okay, you can use just about anything to bisect a line. You can use another line, or you can use a plane, anything that cuts the thing in half. All right, so this plane P, which is clearly coming out at you, can bisect AB at its midpoint. The line X or the line Y, which are on plane P, they can also bisect AB. If you want to cut me in half, you got to go straight down the middle to get 2 symmetric halves. But if you want to cut a line down the middle, anything will do it. A point could cut it, a line could cut it, or a whole plane. Why? Because points are infinitely small. They take up no space. They're just locations, and lines are a string of points. So all you need to cut it is a single infinitely small point or location. So lines or planes will cut it. Interestingly enough, this line will also go through the midpoint and bisect AB into 2 equal halves. Why? Because as long as you're going through that one point, you can cause a bisection to occur. All right, so we say that plane P bisects AB, segment AB. Also lines X, Y, and Z bisect AB. All right, last thing we're going to do is a construction. Do you remember this? This is our second construction for the year. We said now we've got 4 languages. We've got verbal, which is these word problems. We convert off into a second language, which is geometry, often on the Cartesian coordinate plane. Third language we translate to is algebra, and then we usually solve specifically from the algebra. So verbal to geometry, geometry to algebra, and then we solve. Well, constructions is a 4th language. Do you remember what this looks like? You can only use a compass and a straight edge. That's it. And you have to do all your math with a compass and straight edge. No measurement allowed. It's the ancient Greek form of geometry. It's the original form of geometry that was systematized, you know, Pythagoras in 600 BC all the way through Euclid in 300 BC. That's what they used. They did all their demonstrations and proofs using a compass and a straight edge, no measurements, no Cartesian coordinate planes. They didn't have any of that. All right, so we are going to speak this fourth language, which are constructions, only using a compass and a straight edge, a type of geometry. So what's our second construction? It's this: bisect line segment AB. How are we going to do that? Here's what we're going to do. Bypass this. We are going to open our compass to more than half of the distance from A to B. As long as it's more than half the distance, you're good. So maybe open up your compass so it looks like this. Right? At the pointy end here, and with the pencil end, you're going to swing out an arc, just like that. It's got to be more than halfway to B. Swing out an arc. Okay? It should look like this. Then, without changing how wide open your compass is, keep it in the same place. Pick the sharp end off of A, put the sharp end of B, and with that same size, you're going to swing another arc, just like that. All right, now you'll notice the arcs intersect at 2 points. How many points do you need to create a line with a straight edge? Only 2. So you get your straight edge out, and you draw the line right through that first point and that second point, just like that. And what do you notice? This new line you've drawn will intersect your line segment at its midpoint, thereby bisecting AB into AM and MB. Notice, we didn't measure anything. We didn't use a Cartesian coordinate plane to calculate anything. The ancient Greeks never did that. They did all their math with a compass and a straight edge. So in this form of geometry, which we're going to call constructions, you can bisect a line segment using just these 2 tools. Let me show you that construction one more time, in case you can catch it. You are going to put your pointy side on A, and you're going to open up your compass so that it's more than halfway to B, and you're going to swing out an arc. Then you're going to take the compass off the page, put the pointy end on B, and swing another arc of the same length. Wherever the arcs come together forms 2 points. Now you have 2 points, you can draw a line through them. You do that with your straight edge, draw the line with your straight edge. And where your new line intersects your line segment AB is the midpoint, and you have bisected line segment AB into AM and B. Amazing, right? It's crazy what you can do with that. A compass and a straight edge. 4 languages: verbal, geometric, algebraic, and now this language called construction, which is an ancient form of geometry. All right, folks, that's all we got for this lesson. Your homework is 13 through 51 odd. So there it is. There was a modified homework for 5th period. Happy Friday.